Diazo Compunds, preparation of phenol from aniline. Prepare some iodide starch paper for use as an indicator for nitrous acid as follows. Read about 1 gram of starch with a few cubic centimeters of water and pour the mixture into 200 centiliters of boiling water with the solution and dissolve it in a crystal of potassium iodide. Insert pieces of filter paper into the solution and hang them up to dry in a place free from acid vapors. The moist paper can be used in the following preparation. In a 500 centiliters of baker, pour 25 centiliters of concentrated sulfuric acid into 200 centiliters of water and add to the warm solution 20 grams of aniline slowly and with vigorous stirring. Cool and add 100 grams of ice. Dissolve 16 grams of sodium nitrate in 100 centiliters of water and add the solution in small quantities with stirring to the solution of aniline sulfate until the amine has been diazotized. This can be determined by testing the solution for nitrous acid, which will be present when the nitrate has been added in excess. The amount of nitrate which has been dissolved is slightly excess over that required for the reaction. When the larger portion of the nitrate has been added, stir vigorously. Place a drop of the solution on a piece of iodide starch paper. If free nitrous acid is present, a blue spot will form. Continue the addition of nitrate into the solution after throughout stirring and standing 15 to 20 seconds. Produce an immediate blue color with the iodide starch paper. Pour the solution of the diazoamium salt into a flask and heat it at 14 degrees, 15 degrees on water bath for half an hour. Distill with steam and collect about 300 centiliters of distillate. As long as any phenol distills over the distillate will give a color with the solution of chloride. Saturate the solution of phenol with sodium chloride and add the extract 3 times after using 100 centiliters each time. Let the heater solution stand overnight with about 1/5 its volume of sodium sulfate and filter the heater and distill it off from a flask on water bath. Wash it to dryness with some of the covered header and add the solution to the flask. Pour the residue into a small flask and distill using an air condenser. Collect the fraction boiling at 118 degrees, 183 degrees. Calculate the percentage yield. Phenol melts at 43 degrees, boils at 183 degrees. It's soluble in about 15 parts of water at 16 degrees. The yield in this preparation should be about 15 grams. Note that in the preparation of the diazoamium salt, it is advisable to keep the reaction mixture cold during the addition of the nitrous solution, even in the case when the resulting salt is to be decomposed by water. In this way, the formation of byproducts is allowed to avoid a small amount of p-Hydroxydiphenyl is formed as a result of the condensation of the diazoamium salt with some of the phenol formed in the reaction. The compound can be obtained by filtering the hot solution from which the phenol has been distilled. On cooling, p-hydroxydiphenyl separates out in plates which melt at 164 degrees. Preparation of Iodobenzene from aniline. Mix together in a beaker 115 centiliters of water, 12 centiliters of concentrated sulfuric acid, and 10 grams of aniline. Cool the solution and add 100 grams of ice. Diazotize the solution by adding a solution of 8 grams of sodium nitrate dissolved in 14 centiliters of water in the way described in the above experiment. Preparation of phenol. Pour the solution of the diazoamium salt into a liter flask and add a solution of 22 grams of potassium iodide in 15 centiliters of water. Place the flask in water bath heated to 70 degrees, 80 degrees until the evolution of nitrogen ceases. Make the solution strongly alkaline by adding a solution of sodium hydroxide and still with steam. As long as an oil comes over, it is necessary to have the end of the tube throughout which the steam enters the flask passed to the bottom of the latter so that the steam passes throughout the heavy oil and keeps it constantly in motion. Separate the hydrobenzene and dry it with calcium chloride. Filter it into a small flask and distill using an air condenser. Calculate the percentage yield. Iodobenzene boils at 188 degrees. Corrected, the yield should be about 20 grams. Preparation of p-Tolunitrile Sandmeyer reaction. Talking about this, be careful and add caution. In this preparation, cuprous cyanide is to be used. The compound is made from copper sulfate and potassium cyanide. As the reaction involves the liberation of cyanogen, a very poisonous gas, it should be carried out under the hood with a good draught, and care should be taken not to breathe any of the gas liberated. Care should be exercised also in handling the potassium cyanide. Dissolve 15 grams of copper sulfate in 200 centiliters of hot water. Place the solution in a 2-liter flask on a water bath. Heat to boil under the hood and add in a small portion a solution of 55 grams of potassium cyanide. Dissolve in 100 centiliters of water. Leave the solution heating on the water bath and prepare the Diazo compound as follows. Adding 20 grams of p-Tolunitrile to a mixture of 45 centiliters of concentrated hydrochloric acid and 100 centiliters of water and stir. Place the vessel containing the solution in cold water. Add 100 grams of ice and diazotize with a solution of 16 grams of sodium nitrite in 16 centiliters of water, taking precaution to avoid an excess of the nitrate solution. Pour the diazo solution into the hot solution of cuprous cyanide and about 10 centiliters at a time and shake vigorously. Avoid running the solution down the side of the flask. It should fall directly into the solution of the cyanide. This precaution is taken to avoid as much as possible the formation of cresol as a result of the interaction of the Diazo compound with water. The addition of the Diazo solution should take about 15 minutes. Leave the flask on the water bath for about 15 minutes more, and when the evolution of nitrogen ceases, distill with steam on the hood. If the Tolunitrile solidifies in the condenser, turn off the water in the latter for a short time. The steam will warm the water in the condenser and the nitrile will melt. This is as long as an insoluble substance comes over in appreciable amounts. If only a small amount of cresol has been formed, the nitrile will solidify in the receiver and separate the crystals and let them dry. Spread on a porous plate. As the Tolunitrile melts at 8 degrees, the crystals should not be put in a warm place. Weight the crystals and calculate the percentage yield. Save the preparation for future experiment. If much cresol has been formed during the reaction, the product will not solidify. In this case, extract with a small amount of ether. Shake the ether solution with an equal volume of solution of sodium hydroxide. Dry over calcium chloride. Pour off the solution, distill off the ether and distill using an air condenser. P-Tolunitrile melts at 18 degrees and boil at 218 degrees. The heat should be about 13 grams. The preparation of Diazoaminobenzene. Dissolve 10 grams of aniline in a mixture of 100 centiliters of water and 20 centiliters of concentrated hydrochloric acid. Add 100 grams of ice when the solution is cold. Add a solution of 8 grams of sodium nitrite Nitrite in 14 centiliters of water. Dissolve 10 grams of aniline mixture of 7 centiliters of concentrated chloric acid and 15 centiliters of water, and add 15 grams of ice. Pour the solution of aniline hydrolyzed slowly with stirring into solution of the Diazo compound. Dissolve 25 grams of hydrated sodium acetate in 15 centiliters of water and add the solution to the mixture. At the end of half an hour, at about 300 centiliters of water, stir, filter by suction. Wash the precipitate with cold water. Press the diazoaminobenzene on a porous plate and let it stand to dry. Do not heat. Weight the product and calculate the percentage yield. Crystallize a little of the compound from p-Tolunitrile as follows. Digest for 2 or 3 minutes 2 grams of the Diazoaminobenzene with 100 centiliters of petroleum ether. Filter hot, evaporate to about 15 centiliters and set aside the solution of crystallized Diazoaminobenzene crystallized in yellow plates, which melt at 90-80 degrees. It exploded when heated above its melting point. It is insoluble in water and is soluble in benzene, ether, and alcohol. The yield obtained in the above preparation is about 15 grams. Note that the sodium acetate is added to interact with the excess of the hydrochloric acid present. The salt is frequently added to solution containing strong acids when it is desired to bring about a reaction which does not take place in the presence of such acids. As far as preparation of aminobenzene is concerned, you must mix in a small beaker 10 grams of diazoaminobenzene, 20 grams of aniline, and aniline chloride prepared as follows. Dissolve 5 centiliters of aniline in 10 centiliters of concentrated chloric acid. Cool in running water, filter by suction. Press on a porous plate. Allow the salt to dry for about 5 minutes. Heat for 1 hour on a water bath the mixture so that the temperature of the latter is between 15 degrees and 16 degrees. Stir frequently. Dissolve the product in 15 centiliters of glacial acetic acid and pour the solution slowly into 400 centiliters of water, stirring vigorously. After about 5 minutes, filter by suction, wash with water and set aside to dry. Convert a part of the aminobenzene into the chloride as follows. Dissolve 2 grams of the compounds in 10 centiliters of alcohol and pour the solution into boiling mixture in 20 centiliters of concentrated hydrochloric acid and 200 centiliters of water. Boil for 10 minutes and set aside to crystallize. Filter and wash the crystals with water containing some hydrochloric acid and crystallize the rest of the aminobenzene as follows. Dissolve the substance in alcohol in the proportion of 1 gram of aminobenzene to 10 centiliters of alcohol. Heat to boiling and add water until the solution begins to cloud. Set aside to crystallize. Filter off the crystals and wash them with a mixture of equal volumes of alcohol and water. Aminobenzene crystallized in yellow prisms melts at 127 degrees and this is decomposed above 316 degrees. It crystallizes well from hot water in which it is difficult soluble. Preparation and properties of phenylhydrazine in a beaker. Pour slowly with stirring 20 grams of aniline into 170 centiliters of concentrated chloric acid. Put the beaker to a 0 degree in a freezing mixture of ice and salt and add a drop from a separatory funnel, a mixture of 20 grams of sodium nitrite dissolved in 100 centiliters of water until a drop of the solution will lead to deal with a few drops of water, produce a blue color with the iodide starch paper. The mixture should be stirred during the addition of the sodium nitrite. Dissolve 120 grams of hydrogenated stannous chloride in 100 centiliters of water. Cool the solution with ice water and pour it slowly into the solution of the Diazo compound. After an hour, filter off by suction the precipitate of phenylhydrazine hydrochloride using a porcelain funnel or filter plate and hardened filter paper. Remove as much of the mother liquor as possible by pressing the crystals and then transfer them to a flask and add an excess of a solution of sodium hydroxide, extract with ether, dry over and use potassium carbonate and distill off the ether. The resulting oil can be used for the following experiments. If it is desired to keep the phenylhydrazine, it should be distilled as it decomposes slowly. On distillation, it is better to distill it on diminished pressure. The compound can also be purified by freezing it and pouring off the liquid, which does not solidify. Phenylhydrazine is nearly colorless when pure. It melts at 17.5 degrees but at 242 degrees and has the specific gravity of 1.097 at 23 degrees. The yield in this preparation should be about 10 grams. Conversion of phenylhydrazine into benzene. So 13.5 grams of copper sulfate in 100 centiliter water and 500 centiliter flask connected with a reflux condenser. Heat the solution to boil, remove the flame and drop into the solution from a separative funnel. Suspended in the condenser 10 grams of phenylhydrazine. Dissolve in 10 centiliters of acetic acid and 10 centiliters of water. As soon as the phenylhydrazine has been added, arrange the condenser for distillation and distill as long as an oil comes over. Separate the oil and shake it with an hydrochloric chloride until no drop of water can be seen and the benzene is clear. Distill the oil and note its boiling point. Benzene, the product of the reaction, boils at 18.4 degrees. The heat should be about 6 grams. Add 2 drops of phenylhydrazine to phenol solution. Formation of urea derivatives from phenylhydrazine, semicarbamide. Dissolve 1 centiliter of phenylhydrazine in 1 centiliter of glacial acetic acid and 5 centiliters of water. And add a solution of 0.5 gram of potassium carbonate dissolved in 2 centiliters of water. Heat to boiling, cool, and shake. Filter off the precipitate, wash with cold water and crystallize it from boiling water. Semicarbamide melts at 172 degrees. Formation of phenylhydrazine. Dissolve 2 drops of phenylhydrazine in 12 centiliters of alcohol and add 12 centiliters of alcohol and 12 centiliters of water. Add to the solution 2 drops of benzaldehyde and boil for half a minute. Cool, shake thoroughly and filter the section. Wash with 10 centiliters of 10% alcohol and recrystallize the precipitate from 25 centiliters of boiling 15% alcohol. Cool, filter off the crystals and wash them with 10 centiliters of 15% alcohol. Dry the crystal and determine their melting point. Benzyl phenylhydrazine is a white crystal compound which melts at 156 degrees. Note that the reaction between phenylhydrazine and copper sulfate takes place according to the following equation. C6H5NH coordinated NH2 plus QSO4 gives C6H6 plus N2 plus CO plus Q plus H2SO4. Phenylhydrazine is the derivative of ammonia and its salts therefore react in many cases like ammonium salts and the salts of amines. The preparation of semicarbamide from phenylhydrazine salts is analogous to the preparation of urea from amino salts. The equations for the two reactions are similar. Phenylhydrazine is a valuable reagent for identifying aldehydes. The method of preparing the phenylhydrazine is illustrated by these experiments.